every week since 2 years, almost 3 years actually. So we've hosted over 150 events. We have over 7,000 members, which we are part of, and we had over 200 speakers. This is our upcoming events, and so next week we'll be at Apache in San Jose, talking about, we'll have a deep learning toolkit demo by Dato. Then we'll have a pretty large event where we are expecting close to 1,000 people. So make sure to, I'm going to post it probably this week or the following week, but it will probably be full pretty quickly. We'll talk about innovation, and this will be with Steve Osniak and Dave Hitz. And then we'll have a fun panel discussion in San Francisco talking about online dating and big data, and how big data is allowing people to connect, and how these companies collect the data to find the right fits. So it should be fun. We'd like to thank our sponsors tonight, as well as our partners, and of course Perkins Squibb for hosting us. A few words about the Hive. I have a few people who ask me what the Hive is. So the Hive is an early stage data-driven startup incubator, and we are looking for entrepreneurs to start companies at the seed stage, companies developing applications for businesses. We invest from 1.5 to 3 million in each one of the companies, and we work very closely on the technical, marketing, business side of the product with each one of our companies. Some of our recent companies, so we have Deep Forest Media, who just got acquired by Rakuten, Kosei, who just got acquired by Pinterest, a few other ones who got Series A, so they're all doing great and they're successful. So we are now looking for new entrepreneurs and new startups to start. So if you have a great idea, if you want to start a company, reach out to us. And just a few words, MapR is offering some speakers tonight. So if you want to enter the raffle, you can place your cards in the ball at the entrance, and we'll do the drawing at the end. And maybe we can pass around the ball at the end of the event. And we'll have a Q&A session after Neeraja's presentation. And with this, I'll let you introduce yourself.
Yes.
Yeah.
Can you hear me fine? Is it too loud?
A little loud.
Yeah. All right. So my name is Neeraja. I'm from MapR. I'm in product management team, mainly responsible for our SQL and Hadoop initiatives. So Drill is one of the SQL projects that MapR has pioneered and is a key contributor in. So we'll focus a lot on the Drill today. And prior to MapR, I was at Informatica, Microsoft SQL Server team, and then Oracle, Expedia, mostly focusing on kind of building the scalable, distributed enterprise apps, as well as BI and analytics. So that has been my focus. So just to give some context on the topic today, right? So SQL, I think, has become kind of fairly important in the last couple of years on top of Hadoop and in general big data. So what I want to cover in today's session is what are the new kinds of requirements to think about when you are evaluating a SQL technology on top of big data, and how Apache Drill, one of the open source projects, is trying to tackle some of these requirements. Right, so I'll try to actually go into fairly in depth, mostly from a usage standpoint. And I want to keep this interactive, so feel free to let me know if you have any questions on the way. It's a fun topic, so if you have any questions, we can take it. I don't want to wait till the end of the session for a Q&A. So with that, so here are some of the topics I'll cover. So what is the motivation for Apache Drill? So there are a number of SQL technologies already out there. So what is the reason for it? Another kind of SQL on Hadoop, right? So that's where we'll start, and how is it different from some of the other SQL technologies like Hive, Impala, Spark SQL, how is it different? And then I'll do kind of a product walkthrough, so I'll try to do demo here. And then talk about security. This comes up pretty often. So I want to deploy drill in enterprise environment. So what kind of security aspects that it has. And then wrap up with resources. Right. So as I mentioned, feel free to ask any questions as I go through the presentation here. So for those of you who don't know about MapR, MapR is a Hadoop distribution. We focus on providing an enterprise-grade big data platform. Right. On the platform, you can do a variety of analytic workloads, but at the same time, the differentiating thing about MapR is you can also actually run real-time mission-critical applications, not just analytics. So all in one unified platform, you can do both analytics as well as operational applications. And we are recognized as top Hadoop distribution as well as a top-ranked NoSQL database in the key value store by Forrester. And then very recently, it is also recognized as a SQL on Hadoop solution, top-ranked SQL on Hadoop, especially with the inclusion of Apache Drill. So I think before I talk to this slide, how many of you have actually heard about Apache Drill? Okay, how many of you have used Drill, downloaded, played with it? All right. So I think for those of you who have been kind of following Drill, Drill has incubated around end of 2012 time frame. So it has been in kind of solid development for about more than 2 years now, right? And around last year, September time frame, it went into beta. And since then, a lot of users in the open source community as well as enterprise customers have been playing with the product. Several of them are rolling into production. And the community has been evolving it. As you see here, there have been like 7 releases in the past 9 months, each with significant kind of new feature set as well as stability and performance improvements, which fed into kind of the Drill 1.0 release. So it just happened. So May was kind of a big month for the Drill team. And so 1.0 basically represents kind of the first generally available production ready version of Drill, right, that you can play and download and deploy it in your environment. So let me go back and start from kind of what is the motivation here. So most of you have probably seen this graph, right? So data in enterprises is growing fast. And if you look at what kind of data is contributing to this growth, there is structured data, right, which is kind of growing moderately. And then there is unstructured data, which is growing exponentially, right? The unstructured data could be your PDFs, documents, images, like purely unstructured, but it also is, the majority of the unstructured data here is application generated. So things like clickstream, logs, sensor data, and a lot of this application generated data is in semi-structured data formats such as JSON, right? Very, very widely, commonly used kind of application interchange format. So, and if you look at kind of on the data management, data store side of evolution, as you see, right, originally it used to be relational databases only, and in the past probably 5-6 years, the non-relational data stores or no schema data stores, no SQL data stores, whatever you call them, basically they have been gaining a lot of traction, right? So Hadoop, HBase, MongoDB, they all fall into this category. And probably 2009, 2010 is probably inflection point where they became like very important and critical part of kind of enterprise architecture. And what is the benefit they provide? Obviously, they handle much more higher scale than relational databases, like petabytes kind of scale. And then the second, I think last, very important aspect is kind of the flexibility they provide. So you put in structured data, semi-structured data, unstructured data. So they give you a lot of flexibility on the kind of data that you can store inside the non-relational data store. So, and the benefit of that is now developers can roll out new applications pretty fast, right, in weeks rather than waiting for months and years trying to come up with the best schemas and then having to deal with ongoing changes. So more and more data is getting into Hadoop, HBase kind of stores. So there is a natural desire on how do I make it more widely used in the organization, right, which is where kind of SQL comes into picture. So the next question is, okay, so you want SQL on these non-relational data stores, but is it just exactly kind of recreating your relational databases on non-relational stores, or something needs to be done differently? Right, so I have put in kind of the requirements of having SQL on non-relational stores, right? So here, the one part of it is it should have kind of preserved the familiarity of the RDBMS systems, right? Which means that it should have ANSI SQL semantics. It should seamlessly integrate with the BI BI tools such as Tableau and MicroStrategy, whatever is the BI tool that you would use. And it should provide a low latency performance because users want to have good experience while working with these tools. However, the new set of requirements when I think the drill project was incubated, the intention was you need to combine the best of both worlds, right? The familiarity of RDBMS is a key part of it, but then there is the agility of NoSQL, right? NoSQL is extremely popular. One is scale, second is you don't have to create and manage schema definitions in NoSQL stores, right? But just because you want to put SQL on it, you don't want to compromise on the flexibility and the agility that it provides. So no schema management is one of the key requirements even when you're putting SQL on top of non-relational store. And then of course you're talking about big data, so you don't want to really kind of create silos of the data, you don't want to create copies of the data, and it should be extremely easy to use, right? So I'll talk about some of the ease of use features about Drill as well. So Drill, the way we like to describe it is, it's industry's first schema-free SQL engine for big data. So we'll go into a lot of in-depth on what does schema-free really mean, is schema-free really possible. So we'll go into some of the specifics. But at the core of it, the idea is that you are able to point to any data and you start querying using Drill, right? You don't have to define any schema definitions in Hive Metastore or any other centralized repository. So you just point to the data and you start doing the queries. Drill has ability to discover schema on the fly, and then it lets you analyze using kind of familiar ANSYS SQL syntax. So we'll see a number of examples on that. And the second aspect is access to any data source. So data could be in your file system, right? Local file system, Hadoop file system, S3 file system, or data could be in your Hive data warehouse, data could be in your HBase. So whatever is the environment, Drill has ability to access the data, right? It's not just about the data source, it's also about the data types, right? So Drill has ability to, again, we'll see a number of examples to make this concrete, but Drill has ability to work with relational data, but at the same time more complex, multi-structured, nested data formats, schemaless data. So Drill has ability to kind of work with, query, and as well as operate on top of the nested data directly. And it provides industry standard APIs so that you can integrate with existing tool sets. So SQL is a key part of it. And then there is JDBC, ODBC connectivity, and there is a simple REST interface so you can submit queries and get the results back. And it's designed for performance at scale. So it's a distributed SQL processing engine, right? So there is a service that you would run on your cluster which has the ability to take the request, process the request, so it's an engine, right? It's a distributed SQL engine. And so you can deploy it on one node, you can deploy it on thousands of nodes depending on kind of the requirements that you have, right? So you want to process petabytes of data, you want to serve thousands of users, you want to provide a decent SLA. So depending on the requirements that you might have, you can deploy Drill on single node, you can deploy Drill on thousands of nodes. So the optimization is sophisticated enough that it doesn't create bottlenecks for you, either in network or during processing. And then it is designed for extreme ease of use. So one example is you can just download Drill onto your local machine and you can try out. So in most of my demo, actually, I'm going to operate Drill out of my laptop, right? So you just download the tarball and I can start doing SQL queries on my local files, some JSON files that I have.
When it comes to integration with more of the traditional type of BI tools, I mean, the traditional type of BI tools don't really handle complex data, data with nested structures very well. I mean, have they evolved, using Tableau as an example? How well can Tableau handle complex data with nested constructs?
It cannot,
Okay.
right? So Drill is a query engine which can give you the flexibility. So the way to look at it is, basically Drill is like a door to explore this kind of data. And then because the BI tools on the other hand, they require kind of more fixed schemas and so eventually I think hopefully they will kind of evolve, right, with the technology evolution. But at this point, basically you need to kind of bridge the gap. So you explore the data using Drill, you probably create some views, and I'll show a few examples. Then you take them to Tableau or MicroStrategy and visualize it.
Right, just a quick follow-up. You seen any kind of next generation BI tools that would handle complex data with nested constructs much better?
Yeah, so the question is, are there any BI tools that handle the complex nested data types better? I don't know anything on top of my mind, but some of the BI partners that we are working with are actually actually interested in collaborating to come up with an interface where you can explore the complex data more natively
Yeah.
as part of modeling.
Like Tableau.
Tableau, MicroStrategy,
Spotify.
Spotify. Go ahead.
I was going to say you do have a version of a Metastore that you can access, right?
So I'll show all that. I think it will become more concrete as I show more examples. So the question is, do you have a metastore? There is a way for clients to get the metadata, right? So you can do simple things like show schemas, show tables. So we'll see all that in example.
Right. So you
But,
can, you can
yeah.
construct that for downstream if you need to.
Yeah, it's not a central metastore. It's more decentralized. So when you think about Drill, it's all decentralization. So we'll see how that works. But again, from a client access point of view, it does expose metadata so that you can actually do queries and you can do manipulation.
So, to follow up a little bit on that point, if you have more complex structure, you said it bridges the gap. Once the drill stuff is pushed, say to Tableau, does it just create a simple SQL-like structure? So for instance, if there were repeated fields, then it just repeats all the remainder of the rest so that it now looks sort of like a rows and columns type of structure?
Yeah, so you have different options to do that. One is, so Drill supports ANSYS SQL if the data is relational, but if the data is more complex, it has a number of SQL extensions that you can apply to convert into a format which Tableau would understand.
So essentially the only downside being that now you have a much larger structure in
Yeah,
data
it
size.
could explode, right? But this is about big data. It's designed for kind of big data processing, so hopefully that's not a problem.
Right.
Dealing with large data. All right, so I think just to kind of continuing on, what does it really mean, right? So from a traditional approach, if you just have to compare, so there is Hadoop data, there are business users, and the first thing you want to do is you could put data in Hadoop without having to define schemas, but the moment you want to put SQL on it, you have to do ETL, right? So you have to do modeling, you have to do transformation, and potentially probably you have to even move the data if you are using a non-Hadoop kind of environment for analytics. And depending on how complex the data models are, it could take anywhere from weeks and months, right? This is kind of a known, understood problem. And then anytime the source models, data models evolve, you have to repeat the process. Anytime new types of questions that come in, you have to again repeat the process. So there is nothing wrong with this approach. It's just that your data is expected to be static, your answers, your questions are expected to be known upfront. So what Drill is trying to do is kind of complement this kind of governed traditional approach with more of an exploratory approach. So the idea is you have a bunch of data in Hadoop and you want to make it available for analysts, for the users immediately as the data comes into your cluster, comes into your environment, and make it available for ad hoc queries and data discovery purpose. Right, so, and the benefit clearly is kind of more faster time to value, right? Instead of waiting for weeks and months, now you just have minutes and you're able to kind of do analytics and you can answer questions on top of the data. And again, there is easy transition from here to there, which is once you realize that, okay, I understand this data and there is repeatable value in this data, you can always create models. You can create views, you can create tables, and you can always switch to this model, right? If that's what your data models look like. And another way to look at it is with the traditional BI and RDBMS, probably more than a decade back, the data modeling and transformation is typically IT driven, data visualization is IT driven, then tools like Tableau, Spotify, ClickView, they came along, they made the data visualization self-service, but still there is a bottleneck in terms of the data preparation and the ETL part of it. And SQL and Hadoop technologies came along, they don't really kind of change the equation here. What Drill is trying to do is make the data preparation, the transformation, the modeling step optional, right? So it's not trying to be anti-schema, but trying to facilitate a new type of use case, which is the data exploration kind of a use case. Before you go ahead and create, you spend time and money in creating the models on top of it, right? And the idea is basically do kind of end-to-end self-service data exploration. And the benefit is now you have more faster value from the data, which means that as the data comes in, you can act upon it, right? So one fancy term we came up with is zero-day analytics. As the data comes in, you can analyze the data. So as I mentioned, Drill has been out for probably like 7-8 months now, and we see a number of use cases in which customers are leveraging it, right? So the 3 most common use cases are raw data exploration. I have a lot of data on Hadoop or any other file system. It is text files, JSON files. I just want to open it to my users, right? From the second aspect is I'm receiving very complex data from IoT sensor kind of scenarios. My data is very deep, some 8 levels of nesting, pretty complex data, it changes often. I want to open up this data for analysis, right? So more like a complex data, JSON data analysis. And then there is the traditional use case, which is data warehouse offload. So I kind of offloaded all my data for cost and scale reasons onto Hadoop. Then I want to make it available, this full fidelity kind of raw data sets to my analysts, right, to improve on the BI. So these three, I would say, are the most common use cases. And most of the times, one or the other BI tool is involved in trying to get the value of the data, because the audience are analysts and data scientists and users, which are very familiar with those tools. Alright, so I'll briefly cover on kind of the architectural elements, and then we'll go to the product walkthrough. So I touched upon this briefly. So there are, I would say, like four architectural elements. The first one is schema discovery on the fly, right? So I mentioned this, which is with the RDBMS systems, you specify schema on write. With tools like Hive and Impala, you specify the schema just before read. But with Drill, the schema is something that is discovered on the fly, right? And sometimes it is probably very easy, because probably you have metastore definitions, let's say in Hive, already created, in which case Drill can leverage that. Sometimes you might have self-describing data formats such as Parquet and JSON, which already have metadata as part of the file format itself, which Drill can leverage. And again, it can also work with the raw file formats like text files. So the idea is basically leverage kind of the self-describing data formats and don't mandate requiring kind of a central schema definition is really kind of the idea here. And Drill enables SQL on everything. So OmniSQL is one word I took from, I think, one of the analyst kind of articles. So the idea is, I don't think you can see anything here.
Very mysterious.
Yeah, I don't know how my other slides are going to look like, so we'll see.
Same color as the background.
Yeah, so this is saying basically select star from, it's supposed to be dfs.elk. That's the demo data set I'm using. So the DFS is basically referring what kind of data source that I'm querying on, right? So the data source Drill can query, it can query a file system directly. So it could be text files, JSON files, Parquet files. It could be your local file system, Hadoop file system, any kind of file system. So it represents kind of the data source. Another word in Drill is storage plugin. That's how we call it. And another data source for Drill is HBase or MapR which is an enterprise HBase tables that are source for Drill. And then there is, if you already have processed the data, you created Hive metastore definitions, they can be a source for Drill as well, right? So you can do low latency queries on it. And then there is easy API to go beyond Hadoop. So there are early stage plugins for MongoDB and Cassandra, and there is a lot of interest to build a plugin for JDBC, like to connect to the relational databases. So there is an easy kind of modular API to go beyond Hadoop, right? So that's the first part of the namespace, the data source itself. The second part of the namespace, which you cannot see, is in the example is called ELP. So the second part represents, in traditional database, you can think of it like a schema, right? It is, I'm just calling it as like workspace. So in case of file system as a data source, the workspace is a subdirectory. If you are using Hive tables, the workspace is a Hive database. If you are using HBase, then the workspace is a HBase namespace, right? So it basically depends on kind of the data store that you are querying. The workspace definition basically has a different meaning. And the table in Drill is basically, if you are querying a Hive metastore, the table in Drill is a Hive table. If you are querying HBase, it's a HBase table. If you are querying file system, it's just a path to a file. So we'll see a number of examples on this. But with Drill, you can query files, you can query directories. So the whole idea of this is data is there wherever it is, and Drill is able to query it kind of in situ, right? And the beauty is you can combine data from all these places in a single query, right? So I have all my transactional data in Hive, I have my product master catalog kind of information in HBase, I have all my log information in file system, so I can combine all that in a single query, and you can expose it to the BI tools, right? So you're able to bring together the data from different places. The third aspect here is Drill has a very flexible data model. So if you think about data in generally the companies into these 4 quadrants here, the left bottom quadrant is like a most simplistic format of the data, right? It's a CSV, TSV kind of a data where data is simple. So it is strings, integers, dates, simple data types, and every record in that particular CSV has the same schema, right? And then in the context of Hadoop and big data, there are more complex formats like Parquet, which is more nested, it can also support nested data types, and HBase, which is more like a schema-less, where every record has different set of elements. So the most flexible format on the right corner is JSON, right? So this is an example where every element in JSON can be complex or nested. Every record can have its own elements, right? In JSON, everything is possible. So when the traditional RDBMS or SQL on Hadoop is designed for the leftmost, right? That's kind of the typical quadrant to put them in. And the idea is basically if you have a query engine that is designed for that kind of data, if your data is in more complex formats, first you have to do ETL on the data, right? Before you are able to query with it. Whereas Drill's kind of architecture foundation is to process the rightmost type of data. And again, the idea is if you have a query engine that is built for that flexibility, you are able to query any type of data without transformation. It's not just during kind of design time transformation. Drill, actually the engine is built to operate on the JSON type of data, right? Conceptually you can think of it like a JSON document. And so even at the runtime, it is doing all the sorting, joins, aggregations, all the SQL operations directly on top of the hierarchical data model, right? Which means that even at the runtime you don't have transformation, which means makes the nested data processing more efficient working with Drill.
Question about XML.
Yeah.
Does Drill have capabilities to support XML type of documents?
So XML again it fits into kind of the rightmost corner. There is no out-of-box plugin right now, but the file format plugin is a very simple interface that you can implement.
So you working on one that will
No, not at
understand?
this point.
So XML need to convert into JSON and then Drill will access it, something like that?
Yeah, so Drill has, so I'll go into that a little bit more, but the data formats Drill supports out of box, right, are JSON, any text file format, or Parquet. And again, there is easy interfaces to build other file formats. And it can also access through Hive integration. It can also access any Hive tables. So any Hive SERDs, you have them as Hive tables, you query them using Drill. So any file format underlying the Hive implementation, it is accessed through Drill. So more of a meta-store integration.
So, can you join two different formats, like let's say have one data set in JSON, one data set in Hive? Can you do a join like that?
Yeah, so where if hopefully my demo will work, I can show, yeah.
I have one more question. So let's say I have an HBase cluster, I have a regular cluster. Can you join these two as well?
You can. I think, so the question is, can I join HBase and Hive if they are on different clusters? Yeah, you can do. I think the one part of important thing which is actually leading to the next slide here is the SQL engine. This is a distributed SQL engine, so it's going to consider some things like data locality while doing the execution. So the recommendation is that the core daemon in Drill is called Drill bit. So this is something you would run on the various data nodes in the cluster, right? So for data locality purpose, you want to run on all the data nodes on which you want to access the data, right? So it's important that you collocate the Drill bit along with the data node so that it can actually push the processing to that node rather than having to move the big data around over the network. But again, it's possible. There could be some performance implications, but technically it's possible.
So Drill bit will have to be pre-installed on the data nodes, or it will be distributed, via MapReduce, for example.
So let me cover this slide, and that will clarify.
Does it support compressed flat files? Because most of our log files are compressed.
Yeah.
Because I read the documentation today, and it said you support only compressed JSON files.
No, it supports compressed text files.
Flat files.
Yeah. So let me talk briefly about the execution, right? So the core service, the core engine basically is called Drill bit. So this is the service that you would run on the nodes of the cluster. Again, depending on how many nodes you want to deploy Drill on, this is the service that would run. And one very important thing to note here is Drill doesn't rely on MapReduce or Spark or Tez. Drill is an execution engine by itself. It's an execution engine that is designed for hierarchical data It's an execution engine that's designed for scale. So it's a brand new kind of built ground up kind of execution engine. That's why I think the project itself take like 2.5 years, right? So this is an engine built ground up. And it is an optimistic execution engine, so it assumes that queries are shorter and there are not going to be failures, so it doesn't spend time creating checkpoints and boundaries like MapReduce. That is one way to achieve speed. Try to do most of the execution in memory, and it will write to disk only if there is kind of spooling, right? If it doesn't fit into memory, then it will spill to the disk. And it's as I mentioned, it's a scale-out engine, so there is no master-slave architecture here. From a client standpoint, the ODBC, JDBC, REST endpoint, and the CLI, they can submit requests to any of the drill bits in the cluster. That's how it scales. And the drill bit, basically receiving drill bit, would take the request, it parses it, it comes up with an execution plan, it splits the execution among the other nodes in the drill bit, and each drill bit does its job, combine the results, and send it back to the client. So it's completely MPP distributed execution engine, which is designed for large scale. Go ahead.
Are there any facilities at this point for UDFs or
Yes.
UDAFs?
Yeah, so that kind of goes into the extensibility part of it. So there is a Java high performance kind of Java API to build UDFs and UDAFs.
Yeah.
And if you already use Hive and you build Hive UDFs, you can leverage them as part of drill queries as well.
How about other languages like R?
No.
Okay.
Yeah. And another part of extensibility to highlight here is the storage plugins that we just talked about, right? So some of the file formats, some of the storage plugins, they're completely, you can build your own. Basically, it's completely extensible. And even the logical plan, physical plan that happens during the execution, they are well documented JSON APIs. So I might have, like for example, somebody is building a pig parser for drill. So you have a pig parser for drill, which would create the logical representation of the drill plan, which can be executed by the distributed execution engine of drill, right? So it's the DSL itself is again extensible. So I briefly covered it. I think the main goal of drill is let the users be able to leverage kind of the existing tools and skill sets that they have. So JDBC, ODBC is again like a key aspect of the product. And ANSI SQL, I think it's important to highlight that drill is not HiveQL, it's ANSI SQL. So things like correlated subqueries, some of the data types that you would expect to work with BI tools, they would work with the drill, right? There are no new answers.
Does it support analytical functions yet?
No, they are coming in 1.1, end of June.
What is the profile of the users who are going to access Drill? I mean, these have to be quite difficult people, right? To be able to write SQL and understand the behind the scene.
So I think that so the question is what kind of users, what are the user profiles,
Profile, yeah.
right? So one type of user profile, I mean, this is the access of JDBC, ODBC is a typical Tableau user. So this could be your business analyst trying to do kind of the analytics on the data. So that is one profile of the user.
But these users need to know SQL and need to understand the data available to them as well.
They don't need to do SQL, right? So from Tableau, basically, I connect to Drill as a ODBC source, right? And I
Yeah,
bring
right.
in the data and I manipulate in the tool.
Okay, I see. But they still have to understand clearly what data sets they have access to.
Yes, some level of understanding.
Can you talk a bit about performance benchmarks and how it compares to Hive and Spark and the other things?
Yeah, so I mean, I haven't gone into a lot of details on the performance, right? So it is built for performance. So it is an interactive SQL engine. I haven't talked about the columnar vectorized execution. So Drill is kind of a columnar execution engine, which means that it is optimized for formats like Parquet. But again, the internal representation of Drill is a columnar hierarchical data model, so much more efficient in terms of memory and CPU compared to the other SQL products there. So we don't have any published benchmarks out there, but they'll be coming out shortly.
What is the drill actually comparing with or competing with alternative? What is an alternative drill at this point?
So that's a good question.
Can you repeat that?
So from a broader category perspective, right, like a very broad category perspective, it's like a SQL on Hadoop,
So is it like
right? That's one category.
Hawk?
No,
So it would be a scoop or something.
no. It's basically SQL on Hadoop, like Impala or Spark SQL. So from a broader category perspective, it fits